Who is Bedrock Automation? We are a subsidiary of a large multinational semiconductor company that's here in Silicon Valley that's been around for over 35 years. But Bedrock itself is one of the youngest and newest companies in the field of automation. Now, this newness has given us the opportunity, afforded us the opportunity to design something really new from scratch and from the inside out and rebuild a new automation platform. The mission, the objective of the system was to build a system that's simple, scalable, and secure. And the objective of the company is quite simply to deliver open and secure automation to the automation market. So we've filed over 100 patents, and many of them have been received. And we also have received a lot of awards and accolades from industry and media and others. And so that's greatly respected and appreciated. Incorporated in 2013 and shipping for 18 months with dozens of systems and early adopters and customers. What is a platform? So if you take a look at it first, this is a backplane populated with basically with all of the modules and all the components that make up the system. Some of the obvious things to point out will be its extreme robustness. And you'll see that through sealed all metal construction. If the I/O modules are removed, you'll see that the backplane is a pinless electromagnetic interconnect. These are things that address some of the high-level robustness and cybersecurity issues. And so let's take a look a little bit further into the platform, and you'll see the architecture, again, is very, very simple. And while this system can be used from any application to a SCADA RTU up to medium and even very large DCS and PLC applications, there are only a handful of part numbers. And that's one of the more radical effects of designing from the inside out and building modules and systems that are software-defined hardware. If you go left to right, you see on the left we have a universal power module, which works in any kind of a grid, any kind of a power, dual feed, and others. Universal controller that runs an open 61131 language, and a series of universal I/O modules, universal analog and universal discrete, as well as universal network modules for Ethernet and other types. And this all interconnects on a high-speed 4 gigabit backplane. So this makes it up. So there's 10 part numbers, and you can put together a system almost like Lego, hardware Lego, and use your mouse to configure it to do what you want it to do with literally just a very small handful of parts. So again, you can imagine the simplicity and the elegance of the design. So security is obviously a very big issue today, and it's growing all the time. The concept of intrinsic security, it's something that's bolted on versus built in. What does this mean? It means that for us, we were able to use security technologies at the component level, the operating system level, and the supply chain and manufacturing infrastructure to build it, such that similar to a biological virus versus a computer virus, if you solve this problem from the inside out and bring it down to the smallest component, and you vaccinate your biological system, well, you can vaccinate a computer system so that down at the smallest component, the transistors and the electronics that make up the system, they're the root of trust. So we create a technology that allows authentication of hardware, software, and applications right at the module, and then push that technology out. If we look at the impact of that to life cycle costs, a couple of things that are worth pointing out. One is in installation, you'll see how these technologies allow the installation of the systems to be far more simpler and far more robust, and be able to interconnect with legacy technologies as well as the whole emerging life cycle cost of cybersecurity. So that's in summary, the technologies apply to the user really to the areas of cost and security, safety and reliability, and these are the factors that have been driving the design from the inside out. And we're very, very proud of the system, and I thank you for this opportunity to be here today.
Albert, thanks. You know, I know that over the time that Bedrock and Inductive Automation have been working together, sometimes there's been questions as well, what's the sort of a combined benefit? I just want to make a couple of comments and also let Albert make a couple of comments about that, because I think it's worth pointing out. And when John Lester and Dee get a chance to speak, you'll see from the end user's perspective. But I think one of the biggest combined benefits is really when you use open technology and standards, you get a lot of benefit from bringing it all together. OPC-UA, SQL, SSL. It allows us to have cross-platform compatibility, allows us to be able to connect the whole enterprise together, and allows us to be able to add to the system later because of the modular architecture also of inductive automation. So you're sort of future-proofing your system where you don't have to worry about trading it out every couple, 3 years. So it also impacts, I think I mentioned already, the licensing side when one looks at total cost of ownership or getting an ROI on an investment as water districts are looking at the challenges they face right now. When you sell by the server, not by the seat, and just what was talked about by Bedrock in terms of reducing life cycle costs in all areas, these things bring the cost down to water districts who may not be sitting there swimming in cash, no pun intended there. So that's comments on a couple of those bullet points. But Albert, can you say a couple more things in terms of the value bringing together from an intrinsic security standpoint?
Absolutely. The endpoint root of trust, the point that I made a moment ago, this is now being shown how we utilize that with firmware upgrades going forward, and we extend that root of trust and using open standard technologies, security like public key infrastructure, PKI, and transport layer security, TLS, and standard crypto, state-of-the-art crypto. So it allows us to extend security to the SCADA, and we'll be working together, us in inductive automation, to demonstrate how we can secure the SCADA application and push this root of trust into role-based access, biometrics, smart cards, and other technologies that will allow the human factor to be secured. So this is what we're going to be showing and shipping in products later this year. And this is a firmware software upgrade to any system that exists. So it allows security to be extended, to be holistic, and to be intrinsic without additional hardware and costs and complexity. It's security that just happens.